This is multiplication part 1. In your previous video, we talked about some terms called product and factors. We discussed how the answer to a multiplication problem is called a product. As in 5 times 7 equals 35. 35 is my product. That's the answer. It's just a special term we use to call the answer in a multiplication problem. 5 and 7 in that same problem would be my factors. Those are the two numbers that I multiply to get 35. So if I was wondering what are some factors of 35, 5 and 7 would be listed underneath those factors. As part of this multiplication process, we're going to talk about two new terms today, array and repeated addition. An array is a way of displaying objects in rows and columns. So we're going to display a multiplication problem like 5 times 7 in rows and columns. Repeated addition is just that. Addition that is repeated over and over again. So if we take the same problem, 5 times 7, that's the same thing as 7 5s added up all together. 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5 will give me 35. 5, 10, 15, 20, 25, 30, 35. Repeated addition is just that. It's addition with the plus symbols, and it's repeated over and over again to show me how many 5s I need. I needed 7. Okay. Using arrays to show multiplication. We can use an array to show the problem 3 times 4. I can have 3 rows with 4 columns, or I could say 4 rows and 3 columns. It's up to you. I'm going to say 3 rows and 4 columns. So these are my columns. I have 1, 2, 3, 4 columns, and I have 3 rows. 1, 2, 3. I have 3 rows of 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that tells me that 3 times 4 equals 12. Remember the equal sign. Excuse me. Everything on both sides of the equal sign have to be equal. If they're not equal, you need to make sure that they are, or it's a false equation. You cannot use it. You cannot prove it. For this one, we have 6 times 3. Now, I can say 6 is my rows or 6 is my columns. 3 is my columns, 3 is my rows. Whatever one you choose. I'm going to say 6 rows and 3 columns. So I have 3 columns, and I got 6 rows. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 6 times 3 is 18. I want you to stop the video and I want you to build an array to show 5 times 4. Now remember, it doesn't matter if 5 is your columns or your rows or if 4 is your columns or your rows, as long as you have represented 5 by 4. Pause the video now to build your array. Okay, after you've paused, taken a second to build your array for 5 times 4, focus back up here. We have a problem. There are 5 rows. Each row has 4 squares. How many squares are there? That's just relating back to the problem I just had you build within an array. First, you're going to set up your array. I got 1, 2, 3, 4 columns. 1, 2, 3, 4, 5 rows. That's how I decided to do mine. And notice here I labeled the rows for you in the columns just because you normally won't have to do that, but I did label them. Row 1, row 2, row 3, row 4, row 5. Now remember it tells me I have 5 rows. Each row has 4, so my row 1 has to have 4 squares in it. My row 2 has to have 4 squares in it. My row 3 has to have 4 squares, and so on. Step 2. Count all your squares up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Repeated addition shows me 4 plus 4 plus 4 plus 4 plus 4. 1, 2, 3, 4, 5 4s. Gives me 20. I counted 20. Write it as a multiplication equation in step 3. 5 times 4 equals 20. Or you could write it as 4 times 5 equals 20, because remember, the commutative property of multiplication states it doesn't matter which order my numbers are in, they are going to give me the same product no matter what. 5 times 4 is the same thing as 4 times 5. Here's some more arrays I just built for you. I have 2 times 7. Here I have 2 rows, 7 columns. Here I have 2 columns, 7 rows. It just shows you that this is the same array as this, except for this one is just flipped on its side. Same thing here, 3 times 4. This array is the same as this array, except for this one is just flipped on its side. Here I have 3 columns and 4 rows. Here I have 3 rows and 4 columns. I'm still going to get 12 X's in my array, regardless of which way it is put, because the commutative property says that. Over here I have the same problems in repeated addition. 2 times 7 equals 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. That's 7 2's, or I could do 2 7's. 1, 2. Same thing for 3 times 4. I can have 4 3's, 1, 2, 3, 4, or I can have 3 4's, 1, 2, 3. Either way, I'm going to get 12. Here I'm going to get 14. It doesn't matter which way I do it. 7 plus 7 is the same thing as 7 2's added up. Okay, for this last slide, I would like for you to try some on your own. I want you to build an array and write repeated addition equation for each problem. Problem 1, I have 7 times 6. Problem 2, 4 times 8. Problem 3, 9 times 3. Now remember, these do not have to be in any certain way. The commutative property says it doesn't matter how you build your array. Hint, go back into the video for help. If you need help, go back and look over the examples that I provided for you on the previous slides. Thank you.